All right, welcome back. So this time we're going to talk about ML ops with SageMaker, Kubernetes, and container services. But before we get started, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. So ML ops manages the entire machine learning lifecycle from development through deployment and monitoring. AWS offers solutions tailored to different infrastructure preferences, from Kubernetes native to fully managed AWS services. So SageMaker for Kubernetes. Let's go into this. Okay, for organizations already invested in Kubernetes infrastructure, SageMaker operators for Kubernetes trigger SageMaker jobs, training, processing, tuning, and inference. These use native Kubernetes tools like kubectl. This enables hybrid ML ops workflows or gradual SageMaker adoption without abandoning existing K8s investments. You pay for triggered SageMaker jobs, but not the operator itself. Setup requires configuring IAM roles, custom resource definitions, and job definitions primarily through the CLI and YAML. SageMaker components for Kubeflow pipelines serve users managing MLOps via Kubeflow, the Kubernetes native MLOps platform. These components wrap SageMaker processing, hyperparameter tuning, training, and inference jobs into Kubeflow pipelines, enabling K8's native MLOps with scalable AWS ML capabilities. Billing occurs per underlying SageMaker service used. All right. So SageMaker projects. So for full AWS adoption, SageMaker projects and pipelines provide native CI/CD integration with Code Pipeline, Code Build, Studio, Event Bridge, and CloudFormation. You can define repeatable, version-controlled workflows covering data pre-processing, model training, evaluation, model registration, deployment from staging to production, and monitoring. SageMaker pipelines define workflow steps. Projects provide template-driven MLOps scaffolding. Model registry tracks versions and approval status. Integration flows from Git-based source control through CI/CD into SageMaker pipelines. Costs include pipeline steps, meaning training and processing, plus code pipeline and code build executions. So this is gonna be a little outdated, but that's how you would do it AWS style. Let's go to Docker. Okay, so Docker packages applications in isolated, lightweight environments, sharing the OS kernel. Each container runs predictably across environments, simplifying microservices, cloud migration, and infrastructure management. Docker files define images stored in registries like Docker Hub or Amazon ECR. And what's ECR? Let's see. Okay, so ECR is AWS's managed Docker registry integrating with ECS, EKS, and code pipeline, choosing private or public visibility. IAM will protect pulls and pushes, and features would include vulnerability scanning, versioning, tag support, and lifecycle rules for automated cleanup. The costs cover storage and data transfer. And let's see. So let's see about ECS. All right. So ECS orchestrates Docker containers on EC2 or Fargate, and it integrates with IAM, ECR, CloudWatch, and application load balancers. So the three launch types serve different needs. EC2 provides more control with more operational overhead. Fargate offers serverless simplified deployment, and ECS Anywhere runs ECS on your own hardware for hybrid scenarios. IAM in ECS involves two roles: EC2 instance profile, which enables the ECS agent to pull from ECR and write the CloudWatch, and task role grants containers access to AWS services like S3 or DynamoDB. For persistent storage across tasks, use Amazon EFS, working with both Fargate and EC2 launch types. Okay, so how would you do this? We're not going to do this in the in the console, right? But the basic steps would be: you want to create a cluster, right? Select Fargate, launch it, choose the VPC subnets, and you provision that. That'll take 10 minutes to launch, at least, probably 15 to 20. All right. And when you're in there and it's all there set up, you can go create some task definitions with the Fargate launch type, with the operating system, preferably Linux. You'd start setting up the CPU, vCPU, and then container images, right? You start setting up the container images, set the port mapping, and then create the service. At that point, the service would choose the Fargate launch type. You configure that networking within the VPC on the subnets, and then launch it. From there, you'd be able to test the deployment and see what's the target group that it was sent to, make sure the load balancer is healthy, and then check the DNS registration. And at that point, once that is all checked and monitored, or verified that it's live and healthy, you can scale up your ECS service and set your desired task count to what you need. But once done, you want to clean up all that. So you update the ECS service, take the task count down to 0. And if you're using an EC2 launch type, adjust the auto scaling desired and maximum capacity to 0 as well. So this will prevent those ongoing charges. Why? Right? So SageMaker will bill per step based on instance hours for training and processing. ECS Fargate charges for vCPU, memory, and duration with per second pricing. ECR will bill per gigabyte per month for storage plus data transfer. With free pulls from public repositories, that'll save you some costs. The AWS native code pipeline code bill charge for execution time, and the load balancer costs per hour plus load balancer capacity units for HTTP endpoint access. So for the exam, remember a couple of things. When questions are asked about container orchestration, MLOps, workflow automation, or integrating machine learning with Kubernetes, understand these container and pipeline services demonstrate practical knowledge of production ML infra. So that'll be all this time. Hit the like button, subscribe, and share with anyone you know taking the AWS Machine Learning Associate exam. But until the next time, hope you have a good day. Thank you.